All right, everybody, welcome to the panel. We're talking about new technologies and how they are helping learn some new things out in the field. I'm Dan Fredman. I'm the program manager for the Home Energy Report at Oracle. I'm pretty new on the job. I've been here for about 6 months, but I was formerly at BECC, a nonprofit consulting company where I focused on behavior and data science. So this is a really fun topic for me. It's not super home energy report related, but it's definitely on the data and behavior side. And we have a great panel lined up today. We've got a little more time than most panels, but I think everyone's going to have a lot to say, so I'll jump right to it. First up, Liza, go for it.
Hi, good morning, afternoon, depending on which time zone you're at. My name is Dr. Liza Legaspi. I'm the Energy Management Supervisor at SoCalGas. I've been with the company for over 9 years. I've been working for about over 30 years in the field of behavioral science, marketing, advertising. I'm also an adjunct professor at Chapman University. And with that, I'll start my video and share my screen just to preserve the bandwidth. And I believe you can see my screen. So for today, I'll be talking about a project that I have been working on for the past almost a year now, which is called the Innovative Kitchen Management Application. And this started through a research that that indicated that food service is one of the largest natural gas consumers in California. That actually allowed us to explore and understand more about this segment or this subsegment of market. And when we went ahead, we looked at repair data associated to leaks. We look at 10 years actually. And you can see in the chart on the bottom right-hand side that there's a significant number of requests for appliance repairs associated with leaks in the food service or drinking places. The next question was like, what are we repairing? What are we doing in showing these numbers? Actually, what we were repairing were the service orders in relation to ranges, fryers, grill, water heater, and oven, which made sense because these are the equipments or appliances in these facilities. The next question was, what was the most common type of repairs being done? It's basically the connectors, pilot tubing, and burner valves. So that was interesting. And going back to the CEC study, it shows that by addressing emissions in the commercial segment, in the restaurant in particular, you can, while they're not a whole lot compared to other sectors probably, and I don't have that data, but we can say there's a significant amount, aggregate that this commercial segment or sector can save if we were able to address this. So this slide basically proves how large or how important is the restaurant customer, and they do contribute a significant amount in terms of usage. We have majority of them in the LA County. So what were we going to do knowing all this information? So with that understanding, we've developed this plan, which is a proactive engagement to commercial restaurants. And how do we do that? It's about what are our goals or objectives? It's about reducing methane emission associated with gas leaks. It's about increasing efficient appliances and providing an incentive to those restaurants. And also offering an energy management tool that can help educate to understand, for these customers to understand their usage, how efficient or inefficient their appliances are. And this is basically doing it in a proactive way. This before something actually happens, you're addressing it right away. So in terms of identification, who would be qualified, or at least who we think would benefit from this effort, we develop a propensity model with the help of our consultant. We've identified restaurants that are more likely to request for service order associated to those issues, appliance issues that I mentioned earlier. And we also partner in had an outreach to repair or diagnose those appliances. We offer them certain options in terms of financing, rebates, and education outreach. And last but not the least, this is where the innovative technology comes in, is installing sensors, the ambient methane detector sensors, and also consumption monitoring sensors to understand trends that's happening in the kitchen. So it's an appliance level type of information. Understanding this can provide us very meaningful information that we can deliver to our target, part of that enrolled customers, and inspire them to basically, conserve energy and also address these issues before they even appear. So this project is not a one team type of effort. It's actually a lot of groups and teams are helping us to put this together. It's a collaborative effort that supports our mission of clean, safe, innovative, and customer satisfaction. I know this is a loaded slide, but it actually shows the process we're in. It's a step-by-step. There's 4 steps in here. First is identifying those customers that are eligible to participate, inviting them to participate. Once they've been invited, they are broken down into 2 groups, wherein those that have high propensity to have issues in their kitchen, and then the other part is the lower propensity have an issue. And the approach is a little different. The higher propensity, we send our technicians there to do a sweep, what we call a sweep test, and identify issues, repair those issues. We're offering incentives, or when I say incentives, it's benefit to the customer, wherein we're repairing it. We offer them, if there's a replacement for the appliances, we offer significant rebate and also a financing option if they need to replace those appliances or equipments. Those with the lower propensity, what we're doing is we're still going out there, but it's more of an education effort and offering them low cost direct install measures. And on the 3rd step here is that after we've done all the legwork and they're on board and we've checked their kitchen, we've met with them, we now install the detection sensors, which is a combination of a flow meter that are placed in appliances or equipments in the kitchen to understand appliance level usage, and a methane detection sensor that can detect ambient methane only. And basically, what's really important with these devices is not about the alarm or the triggers, but it's more about the trends. Are we going to see a trend in here? Can we establish benchmarks? Those are the most important, crucial thing that these sensors can actually help us. And lastly, this information that we're collecting together with the appliance level information, together with the whole building usage, can help customers really understand the relationship of the appliances that they have in their kitchen and how that is affecting the big picture of their operations too. And if there's any personalized, customized suggestions that we can provide to them, and that's more actionable. There's also an intervention component, a behavioral change component, which will be launched later, probably next year, which is more of a goal setting and a reward option, wherein the customer can establish their energy savings goal. And when they do, and they're the one who's establishing it, and if they achieve it, they get rewarded for it. So Milestone. Currently, we have 70 restaurants who are already enrolled in this project. And you're seeing on the right-hand side an actual restaurant visit wherein we look at the kitchen. Our technicians are going around the kitchen and looking at the issues. We're doing a sweep test and we're addressing these issues. We've visited 10 restaurant locations by the field technician. 34 leaks have been identified, and majority are basically coming from incomplete combustion. So there's a lot of maintenance that these kitchens require. There's 21 natural gas appliances that we have repaired as of today, and 8 locations visited by a third party to offer them low-cost measures. The calculation down here is preliminary, it's not finalized. We're working with several third party in terms of really establishing and showing how successful, what we're doing. I mean, I believe it's successful because, for one, we're detecting something that a customer didn't call us. We're actually approaching them before they even call us, because they're probably not even aware about this. So this is a metric for success, because like any project, you want to march towards, an end goal. And here's like how we're looking at establishing it, or looking if this will be successful, since it is a test and learn project. Is basically quantifying those ambient methane gas emission that we've reduced, looking at usage, looking at the repairs we've done, establishing the effects of pole setting or loss aversion. For example, like I said, if a customer establish energy saving goals, if they achieved it, they get rewarded for it. So there's more interaction. There's more. It's not just serving an information. They're actually interacting with the information that they're receiving. It also enables us to enhance customer engagement and service. It's not a one-way communication, but a two-way communication is like delivering the information. They're interacting with the information, and they're telling us also what we can do with that information. It's about the evolution of the model that we've developed. So there's a lot of benefit also for SoCalGas, reducing leaks in the gas system, increased efficiency of customer equipment. And this allows us to develop our business case to expand traditional energy efficiency program as well into the opportunity to pursue broader solution. So this is the innovative, and I'm proud to say I would think this would be the first time this is being done. And that's it. And this is my contact information. And if you do have questions, just put them in the chat and I'll try to address as much as I can. And with that, I'll hand it back.
All right. Thanks, Liza. Really cool. Yeah, so like she said, if anyone has any questions for Liza, please drop them in the chat and she'll either answer or we'll get those questions to her and she can follow up with you. Next up is Jackie Berger and Ben Adams. Jackie is the president and co-founder of APPRISE, a nonprofit research institute. Her recent work focuses on low-income solar energy efficiency and energy bill payment assistance, as well as market rate and residential energy efficiency programs and non-energy impacts for energy efficiency programs. Ben is a partner at MaGrann Associates, a sustainability engineering company based in New Jersey. He's a 30-year veteran of energy efficiency program design and implementation, focusing on residential new construction and retrofit. And I will also add an occasional co-panelist with me in previous sessions. So welcome to both of you and thank you for, you're gonna be talking about some really cool stuff relating to thermostats. And I'm gonna drive this presentation. So let me get my screen up and running. Okay, and Ben or Jackie, can you tell me if I'm displaying the correct one? Or should I swap?
You're showing the notes.
Okay,
Perfect.
should be good now.
Thank you, Dan. We're going to be presenting today on residential thermostat settings and temperature preferences. And this is a study that was a collaboration between APPRISE and MaGrann. And we became interested in this topic when we were working together on a smart thermostat pilot program and realized that there really wasn't good public data on how households set their thermostats. Next slide. So we'll be talking today about the study and the methodology for the study, and then I'll turn it over to Ben and he'll talk about the results, what we found with respect to thermostat settings, temperature setbacks, thermostat types, and the recommendations that we have based on the study. Next slide. So the goals of the study are to understand thermostat set points for households in the Northeast, to develop information on the use of setbacks in the winter and in the summer when households are away from the home and at night, to estimate the penetration of programmable and smart thermostats, and also to develop information on how smartphone apps are used and how other features of smartphones are, of smart thermostats are used. Next slide. I think it's important to talk about the methodology when you're understanding the study to know what the response rates were, what the sample was, and how the survey was conducted. Next slide. So the sample that we used was a purchased address-based sample. It covers nearly all US households, and we focused on the Northeast, the New England region, and the Middle Atlantic region. And we selected a random sample of 2,000 households stratified by state. Next slide. The methodology that we used to implement the survey was that we first sent an advance letter that explained the purpose of the survey. It provided a link to complete the survey on the web. It also provided a toll-free number so the household could call and complete the survey all over the phone. And it also notified the household that APPRISE would be calling them to ask them to complete the survey over the phone. When we sent the advance letter, half of the sample was sent a $5 bill with the advance letter and half was not, to test how that impacted the response rates. About 25% had an email address, so they were also sent an email with the same information as the advance letter, and they could click right on the link to complete the survey. Then we made calls to all of the households that had valid phone numbers during the day, evening, and weekends. On average, 7 calls were made. After 7 days in the field, we sent a postcard, and then after 12 days, we sent another email. So after 1 month, we did find different response rates. 12.5% of those who were sent the $5 bill completed the survey, compared to 6.2% of those who were not sent the $5 bill. So we sent a second advance letter, and this time we sent the $5 bill to those who had not received it in the first letter. Next slide. So I think it's really important to look at the response rates, and this kind of survey is very difficult. When we do surveys with program participants, we usually get response rates of 50, 60, even sometimes 70%. But when you're talking about households that aren't in a particular program and it's not even tied to a particular utility, it's much more difficult. And overall, we achieved a response rate of 23%. Now, because this was an address-based sample, we only had phone numbers for 70% of the sample. So if we just look at the sample that had a working phone number, we had a 30% response rate. And within the sample that had a phone number, an email address, and an address where the advance letter was not returned, we had a 33% response rate. And about half completed the survey online and half by phone. We found that the single-family homeowners were overrepresented, so we used weights to better represent the overall population. Next slide. And a little bit about the terminology. When we talk about a setback in the winter heating season, we're referring to turning the thermostat down to a lower set point, a colder temperature. In the summer cooling season, a setback refers to turning the thermostat up to a higher set point, a warmer temperature. And while the nighttime is generally considered the period for energy savings, this is not true in the summer because households do like to sleep with their home at a cooler temperature. Next slide. And Ben will now present the results from the study.
Thanks, Jackie. So yeah, let's take a quick deep dive into what the data told us. And Dan, if you are able to put our audience question into the chat, I'll be referring to that later if we can do that. If not, that's fine too. Next slide, please. So the average winter daytime temperature among all single family respondents was found to be 69 degrees. And that's right between the 68 degrees typically thought of as an efficient at-home setting and 70 as the default that many consumer-grade thermostats use. And on average, households are using a lower set point when away and at night, so that seems like good news overall. Next slide, please. But nearly half of single-family respondents are not practicing winter setbacks, and this increases to more than half among multifamily residents. And note that to reach the typical energy-saving default setback, that's a manufacturer default, of 62, a full 7 degrees of setback would be required, but only 17%, a real minority, are setting back that much. Next slide, please. And here we see that in summer, the average set points appear fairly consistent throughout the day, 72 to 74 degrees, regardless of occupancy. Next slide. However, even more households are not practicing setbacks in summer than in winter, meaning they're not modifying the temperature at all when no one is home or at night, more than half in both cases. And so as Jackie alluded to, what's really interesting here is that about 2/3 of households report turning down the temperature at night in summer, meaning they prefer to sleep cooler in both winter and summer. And this is actually the opposite from some conventional wisdom of some manufacturer default settings that regard nighttime as the potential energy saving period in both seasons. In reality, for 2/3 of the households that responded, the energy saving period in the summer is during the day, not at night. And I'm just glancing at the chat to see, let's see, it looks like at least one respondent likes to sleep cooler, and that is generally what we found. Next slide, please. And here we see that this appears to be compounded by the age of occupants. In each of these categories, households with an elderly member consistently report higher average temperatures for all periods, including at night in both seasons. Next slide, please. And it's worth noting that more than 1/3 of respondents reported that they do sometimes deploy uncomfortable set points in order to save energy, and that they were more likely to do so during the day. Only 58% said they never experienced this. Next slide, please. But looking at the frequency of thermostats by type, smart thermostats still represent a small minority among the responding population. 16% is low, and multifamily skews that to 12%. Next slide, please. On the upside, smart thermostat households reported a substantially higher rate of setback in the winter when no one was home. So 71% setting back versus 51 and 59 for conventional thermostats. Next slide. In terms of our recommendations, we believe the data emphasizes the need to treat elderly and non-elderly households differently, and that it may be important to not to activate a default energy saving protocol for elderly households in particular without speaking with them first to determine their occupancy patterns and comfort thresholds. Next slide, please. Keep in mind that some households may already be conserving and may even be using more aggressive set points than your programmatic defaults, and that the best way to do what's right for the customer is to speak with them prior to making assumptions. and have the installer set up protocols prepared in advance for a variety of different occupancy and demographic scenarios so that they know what to do once they encounter a specific household. Next slide, please. Finally, smart thermostats do represent an excellent opportunity to drive savings based on the still low penetration rate. And this may be especially true when there's an integrated or accessory in-home occupancy center that can automate home and away settings. Since our study also showed that some residents fail to follow through on fully setting up the app, effectively disabling this feature for smart thermostats that depend on geofencing to trigger home and away settings. In other words, if the smart thermostat is dependent on the app being set up to trigger those home and away settings, that app has to be set up in order for that to happen. So those are the highlights of our conclusions, and we'll be happy to discuss more at the end of the session. Thank you.
Thank you, Jackie and Ben. So, as always, really cool stuff. I'm going to introduce our next speaker, Toby Elushakin, I believe is the way it's pronounced, but please correct me if I'm wrong, Toby.
That was correct. That was pretty good.
Okay, cool. I'll call you Dr. Toby for now. Dr. Toby is a research analyst at Trilateral Research working within the Energy and Climate Cluster. I believe he's coming from across the pond in the UK today, so thank you for joining us. He currently works as the project lead for Trilateral on an EU-funded project called, I don't know if it's EERA data or ERA data, but he'll tell you more soon. He also has a PhD in energy and power from Cranfield University in the UK. Before I hand it over to Toby, just want to let you know he's going to talk about this project, and it assesses multiple benefits that arise through energy efficiency measures applied on single buildings. And it will create a software solution and related database to help municipalities and regions perform these assessments. So I'm personally looking forward to hearing more about this, Toby, and take it away.
Thank you. I will try to share my screen now. Hopefully that works. All right. Dan, could you confirm if you can see my screen?
Yeah, I can see it. Thanks.
All right. Thank you very much for the introduction, Dan. So good evening from here in the UK. It's about 8 o'clock, actually. My name is Toby, and I'm here to just talk about a data framework which my team and I created to ultimately help promote energy efficiency-based renovations within EU buildings. Now, just to go to the basics, I'm sure a lot of us here know what energy efficiency is, but just to state the obvious, energy efficiency is simply the ratio of the output of performance or services or goods or energy to the input of energy. And essentially, the higher this ratio is, the higher the efficiency. Now, as of 2018, in the EU, buildings represent around 40% of total energy consumed and account for about 36% of the carbon emissions release. Now, around the world, the figure is closer to about a third, but then that still constitutes a large number as well. Now, in the EU, energy efficiency is recognized as a first fuel, mainly because of its competitiveness and the fact that it's cost effective. It's recognized as the first point of contact, the first point to go to when looking to reduce or get to net zero emissions for buildings. Now, in buildings as well, energy efficiency contributes to improved comfort, reduced bills, reduction in energy poverty, and reduced energy demand. However, and we've seen this from from our research and literature study in understaffed public authorities and understaffed municipalities, essentially, we see that decisions on building renovations are usually taken without considering the data. Now, this is because a lot of the time, data is not being tracked at all. And when it is, it's quite difficult to access. Sometimes it's scattered in many different databases and even difficult to utilize for decision making. So this is a problem because data on environmental, socioeconomic, health benefits, or wider benefits, as we would like to call them, is crucial to helping to accelerate the implementation of energy efficiency benefits within buildings in the EU. Now, for our project, Eradata, what we found was that there was a lack of adequate knowledge and understanding of the impact of energy efficiency-based renovations on buildings within the EU. And these impacts could go just further than the economic impacts, but looking at many of the wider benefits, looking at the health benefits, environmental benefits, impact on reduction in bills, on comfort, and things like that. Now, Eradata aims to essentially operationalize the energy efficiency first principle. This essentially just means taking into account the cost-effective energy measures in shaping policy and making relevant investment decisions. Now, the project assesses multiple benefits that arise through these energy efficiency measures applied on single buildings. And we have at the moment created a software solution and related databases which help municipalities and public authorities, as well as regions, to perform these assessments, to see the impact of investment in energy efficiency-based renovations, and also go a step further by comparing them to supply-side investments. So as part of this project, we proposed a data framework, which essentially just helps with the overall goal of the project, which is development of a decision support tool, and helps with the assessment of the impact of energy efficiency-based investments by taking into account relevant building stock, energy, socioeconomic, and indoor environment data. This framework essentially begins with the definition of requirements based on different calculation models on which the tool itself is based. So these models include the energy demand model, socioeconomic model, life cycle assessment model, indoor climate model, and supply side assessment model. Now, after that, data is collected, and for this project, we have 3 partner municipalities: the municipality of Belenge in Slovenia, the region of Andalusia in Spain, and the city of Copenhagen in Denmark. These 3 cities form our front-runner partners as part of our consortium and helping us essentially to co-develop the tool and act as our primary testers, essentially. After the data is collected, the data is cleaned and then stored and eventually fed into the decision support tool. In figure 1 here, you can just see a quick overview of the data framework. Now, on here, where we see collect data, the data is collected, well, essentially what we've done is collect data on a building, municipality, and country level. So not just looking at one framework for data, but looking at data at different levels. In figure 2 here, we just have an example of how our databases essentially have come together in different buckets, if you will. First of all, we have minimum requirements, which essentially just represents the minimum amount of data that will be collected for the decision support tool that we're building to run. For it to run on a basic level, there's a minimum amount of data that is required to be collected from each municipality, and this includes primarily building geometric data, so building area, location, building height, width, window height, number of windows, and things like that. And this is something we refer to as real data because it actually represents the condition of a specific building. Then if we move one step further, we look at desired data. And in this case, we have a combination of real data and what we call default data. And this is data that represents the condition of a specific area. So maybe a municipality or a region or a country. Now, in this case, we combine real data, which consists of a number of more variables. We combine them with some default data for the region as well as for the country, so such as weather data, and try to create a more robust and accurate picture of the conditions within that environment. And then lastly, looking at the biggest bucket, we have detailed data, which essentially takes into account all the widest collection of data that we can get in order to get a more accurate assessment of benefits of investment in any type of energy efficiency based renovation. And in this case, we have a combination of real data, regional default data, national default data, EU default data, so that's a continent level, and then international or scientific or modeled default data. Here, I just try to put up a screenshot of our tool at the moment. Admittedly, it's not at its finest moment, but then it's still currently being built, and it's going through different iterative phases. But this is a screenshot of our tool at the moment. Now, in terms of what we've gotten so far, data has been collected for more than 5,000 buildings across the 3 different front-runner municipalities. Data has been cleaned to sort out a number of issues like duplicate data, filling in data gaps, harmonizing data formats, ensuring that column titles or column names are harmonized across the board, and ensuring that data types are also harmonized as well across the board, across 3 different municipalities and across different databases. Like I mentioned, data is stored in different databases for each municipality, and data is then transferred onto a template and imported into the decision support tool to undergo impact assessment, essentially. In conclusion, a data framework has been developed to help assess the impact of energy efficiency-based investments in 3 different municipalities. The data for primary and secondary implementers have been successfully imported into the decision support tool. So at the moment, we've got more than just our 3 primary implementers. We've got a few other cities who have signed up to help test the tool. We're currently in the beta testing phase, and that will begin in December. And at the moment, select renovation cases have already been assessed by the decision support tool. So we have a few test cases, and we've seen some encouraging results, but then they will need to be validated in order for those results to be published eventually. Thank you very, very much. If you'd like to contact me, my contact details are on the screen. Thank you.
All right, thank you, Toby. That was great. It looks like we've got a pretty quiet chat room today, but everyone please feel free to drop some questions, discussions, any guesses on how soon the leaves are going to completely drop out of my background in Vermont. Up to you. Next up, our final speaker of the session is Mariana Egea-Casalduc. I hope I pronounced that right. Okay, cool. Mariana is an ORISE Science, Technology, and Policy Fellow with the Department of Energy in the Buildings Technology Office. US Department of Energy, by the way, I forgot to mention that. Supporting the Better Buildings program to elevate leadership in energy efficiency in the healthcare and hospitality sectors. And today she's going to talk to us about the Department of Energy and how they are driving innovation through the Better Buildings Low Carbon Pilot. The goal of this 2-year pilot is to understand and demonstrate how organizations can achieve real carbon dioxide emissions reductions. Mariana and I have talked a little bit ahead of her presentation, and again, I keep saying this, but they're all going to sound really cool, and I'm really excited to hear what she says. So Mariana, take it away.
Awesome. Thanks, Dan. And I appreciate the new hat. Keep switching it up. They're hilarious. Awesome. And Dan, let me know when you're ready to share my presentation. But while Dan gets that up, again, my name is Mariana, and I'm going to be talking about the Better Buildings, Better Plants, Low Carbon Pilot, and how we are driving innovation through that pilot program, which is primarily informed by robust stakeholder engagement efforts and the real world experiences of building owners and operators.
Okay,
All right.
Mariana, you good to go?
Yep.
Okay.
We can skip 2 slides. Perfect. Great. Now, before I dive into the low carbon pilot, I'm going to briefly overview the Better Buildings, Better Plants initiative for those of you that are not familiar with the program. Better Buildings, Better Plants is a public-private partnership by the Department of Energy, where we work with over 900 partners, stakeholders, and market leaders to accelerate investments in energy efficiency technologies and carbon reduction strategies. Better Buildings, Better Plants partners represent a diverse cross-section of U.S. building owners and managers, including commercial building owners, multifamily residential building managers, and those who own or manage schools, hotels, retail buildings, hospitals, manufacturing facilities, utilities, and local and state government facilities. Next slide. Wonderful. An increasing number of our Better Buildings partners have set aggressive goals for carbon dioxide emissions reductions. And while there are known strategies for meeting some of these goals, innovation is critical for meeting the more aggressive goals. For this reason, we launched the Low Carbon Pilot. This 2-year pilot program aims to understand and demonstrate how to achieve real carbon dioxide emissions reductions. The Low Carbon Pilot is designed to really dig into the building level, identify barriers to going low carbon, and explore how we can overcome those, either by creating new resources, pulling in different stakeholders, exploring existing technology solutions, or identifying the need for new transformational technologies. And we understand that these decarbonization targets are aggressive and cannot always be met. But the Low Carbon Pilot was designed for organizations who are willing to have candid conversations with us about their struggles and challenges to going low carbon openly, as well as sharing their successes. Next slide. Through this 2-year pilot, Better Buildings partners work with a team comprised of DOE staff and contractors, but they're also paired with national laboratory experts who provide technical assistance and help them establish baselines and set goals. The goal of the Low Carbon Pilot is to publish and broadcast real world pathways to going low carbon and encourage other organizations within the Better Buildings ecosystem and beyond to replicate them at scale. Next slide. Perfect. Now, through the Low Carbon Pilot, the Department of Energy is currently working with 65+ industry leaders. Better Buildings is a free and voluntary government program that's primarily informed by partner feedback and input. And we look to our partners to tell us about the obstacles that they face out in the field. And in return, everything they share with us informs our priorities, how we structure technical assistance, the resources we develop, and complementary programs we create to accelerate their process. We also use their feedback to inform DOE's investment decisions in research and development of new technologies. And by celebrating our partners and highlighting their projects, in case studies or through Better Buildings, Better Plants Summit, which is our annual leadership symposium, our team aims to encourage our partners to continue on this path and to continue with this positive behavior and prioritize energy efficiency and decarbonization in their work. Now, on the slide, we have our priority waterfall. We use this priority waterfall to ground our partners and help them prioritize and plan out their projects. Of course, we encourage our partners to focus on energy efficiency first, and also help them identify technical solutions relating to electrification, climate risk, and resiliency. This first part of the priority waterfall is where we really push partners to think long and hard about what's doable for their building type in terms of building performance and ultra-high energy efficiency. A lot of organizations get really excited about renewables, as they should, but overlook all of the room for improvement, energy reduction, and cost savings that they can achieve through energy efficiency. Some folks are simply unaware of how they can make significant progress towards decarbonization with ultra-high energy efficiency alone. And it's only after we go through energy efficiency solutions with our partners extensively that we encourage them to then explore combinations of on-site renewables integration, grid interactivity solutions, as well as off-site renewables. This priority waterfall is also the base for our action plans. And partners develop these action plans with the guidance from our national laboratory experts that they're paired with. And these plans help our partners enable projects because they break down those big low carbon goals and help them identify their immediate next steps, their near-term milestones, as well as actionable energy efficiency projects. Next slide. Great. So this is just a snapshot of the 65 partners that are currently working with us on the low carbon pilot. This pilot was launched this last summer, and recruiting is currently closed for the pilot program. Next slide. Great. So like I mentioned earlier, partner input and feedback informs everything we do through this pilot program, including the resources that we develop. Through the low carbon pilot, partners let us know that they would benefit from high-level technical resources on decarbonization strategies by building type. The Low Carbon Technology Strategies Toolkit, which you can see here on a screenshot of it on the slide, was developed to aid owners and operators of existing buildings in planning retrofit and operational strategies to achieve deep carbon reductions. These strategy documents supplement existing energy design guides developed by the Department of Energy, where new construction is a focus. So it's a complement to those existing resources. So there are low carbon strategies currently available for 10 building types, with a supplement for commercial kitchen equipment. And recommendations are grouped by technology, with recommended actions categorized as either simple, immediate, or advanced. Now, on a separate note, I'm sure you're all aware that there is also a lack of market-ready heat pump technology, namely cold climate heat pump technology. And this is a huge barrier to electrification, specifically in the northern regions of the country. So in our conversations with partners through the pilot program, we were asked repeatedly, what about heat pumps? And for our partners, heat pumps are a technology that they're very eager to embrace, but really they don't know much about them. And they were right to think this way because a lot goes into heat pump interventions. For example, planning out technology life cycles to determine the perfect intervention timeline. And there are also a bunch of different workforce implications. And the fact that there aren't a lot of installers out there that have the skills and knowledge to successfully carry out a heat pump intervention. And this is why we're currently in the process of developing an additional resource that is, just a basic but comprehensive resource on the decarbonization of heating that allows commercial owners and operators to identify key considerations and available technologies based on their current HVAC and water heating systems in existing buildings. Next slide. Wonderful. So there's a lot to come from the low carbon pilot, a lot of different resources and a lot of investments in new and emerging technologies will be made. And all of those decisions are informed by the feedback and input of our partners that are key to the low carbon pilot and its success. And if you have any questions of our partners and who's involved or how you can get involved with other initiatives the DOE has launched focused on decarbonization, please feel free to reach out to me. There's my contact information, and I'm always happy to chat.
Okay, thank you, Mariana. So at this point, we are done with the formal presentations. Didn't have a chance to change my hat, sorry. But could I get all the speakers to come back on video? And right now there's a couple questions for Mariana. I think we'll just ask them in the group here before we break out. And first question from, I think it's Oriane or Oriani. Why is the DOE not partnering with K-12 schools on this pilot?
The DOE is 100% partnering with multiple K-12 schools on this pilot. There are a lot of different sectors represented, including K-12 schools, hotels, hospitals, retail buildings, manufacturing facilities, utilities, and local and state government facilities. So, schools had a really difficult time during the pandemic and these last couple of years, and they're definitely a priority for us here at the Department of Energy and in Better Buildings.
Great, thank you. Yeah, and there's this follow-up. Therese asks, what about lab or tech? I'm not sure if there's enough context to that question, but let us know, Mariana, and maybe Therese can give us some more context.
Yeah, I'm assuming that this question revolves about technical assistance. So I'll answer that in two parts. So
no, it has to do with we have a pilot with Genentech where we're doing a decarbonization of their natural gas boilers. And where we found that we can save like it's an extraordinary amount, more than 50% of the energy savings just by better controls. So I was wondering if you guys were looking at any decarbonization techniques as well. And so Genentech would be more like an industry or lab type building.
Yes, I'm not really well versed in our work with boilers specifically, but through the Better Buildings Initiative, we have what we call tech teams. And those tech teams are comprised of national laboratory experts. And we have tech teams for a lot of different technology areas, including HVAC, lighting, building envelope, renewables integration, and water conservation and energy efficiency, including HVAC and space conditioning. So I'm sure we cover boilers somewhere, but we provide a lot of technical assistance for our partners in those spheres. And they also, bring up specific technology barriers. And the benefit of having these tech teams and the national laboratories at the disposal is that these labs are huge. So somewhere we'll be able to find an expert in that specific technology field, and we'll be able to connect them with partners, and we'll be able to, help them better understand the potential for energy efficiency reduction with that specific technology type. And like I mentioned, those tech teams are available for the broader Better Buildings program. And the benefit of being included in the pilot is that you are paired with one expert specifically that has a lot of background and experience in your sector and your building type. But like the tech teams, that expert can pull other scientists into conversations and calls and help our partners navigate these various obstacles.
Cool. Thank you for the questions and the answers. I guess we have a bit of time, and before we send you all off into your respective rooms, I had a question for the panel, and maybe you can each take turns. Because you're front and center, I'll start with Ben and Jackie. This is a broad question, same question for everybody, but in general, given what you've shared with us today, going forward, what are you most excited about the prospects for the work, the research, the applications, the use of technology in the field? Where do you think this can go? Blow it wide open.
I'll start if that's okay. I think what I'm most excited about is all of the remaining opportunity to provide households with smart thermostats. And I think that that's really could potentially be of great benefit in reducing energy usage, because we found that so many households are not practicing setback, and that setbacks are much more commonly practiced, at least in the winter, when households have a smart thermostat.
Yeah, I agree with Jackie, and I would just add that what's exciting to me is taking account of and learning more about how people actually interact with their technology and how important it is not to make assumptions about that. So actually, I'll just quickly address a comment that was in the chat from earlier about the runtime of the AC during the day. And absolutely correct. How much energy is actually saved depends on the temperature differential of the setback and the outdoor temperature, which is typically higher during the day. But if we assume that people want to set their thermostat a certain way and we default the setup of the thermostat to our assumptions without talking to them first, in some way getting their feedback, it may not necessarily be how they prefer to use and set their thermostat. And in doing that, we actually risk turning them off to the technology. So, you know, from our perspective, I think we see huge opportunity. We also see the opportunity to optimize and not screw it up in terms of how the customer actually ends up using it, especially if they didn't ask for it and it just appears on their wall through some program.
Absolutely. Will, how about you? What are you most excited about with the project?
It's a really good question. Hi, everybody. I hope you could hear me okay. Let me know if you can't. So looking at the restaurant industry, I've been in the restaurant industry for over 20 years. Looking at the technology out there, and behavioral applications, there's a lot of opportunity for growth, for identifying ways, and identifying ways we could help our customers save energy. So I don't know if I could put a number on it, but I think the number is high in the opportunity.
For sure. Cool. Good to know. Toby, off to you. What do you think is what's most exciting going forward from this research and this project?
Yeah, I'd say for me, the first thing I think about when asked that question is the level of scale that the work that we're doing can actually get to. Like I mentioned in the presentation, we are working with 3 front-runner municipalities at the moment to help test the tool. And you know, just from working with these municipalities, we just find that, first of all, tracking data on building stock is almost non-existent within the EU. I'm not sure about how it is within the US, but within the EU, it's not something that's established. Just being able to track data on buildings, then also track renovations over time, and then tracking data that extends beyond just building geometric data. So looking at U values, G values, and things like that, things that relate more to energy efficiency. Being able to track those things and then store them in accessible database where decision makers can actually get those things in order to help to make decisions, because obviously if you have good data, you're able to use that data to make good decisions, and then to go from there to actually having the tools to use that data to make good decisions. So then looking at those different steps and trying to develop a good pipeline in that respect for the municipalities that we are working with, we can see a really nice, a really good opportunities for scale, in terms of many of the municipalities. A lot of them that are not even as technologically savvy as the municipality that we're working with. We're working with the city of Copenhagen, which is actually quite recognized as one of the more technology forward cities within the EU. So we see great opportunities for scale in that regard, and I think that, I would say, is the most exciting thing.
And before I toss it to Mariana for the same question, I just thought, Toby, as you talk about scale and doing this work in the EU, do you see any obstacles or opportunities to translate the sort of framework and work in the EU to other regions? Like, you know, for example, the United States, like anything that doesn't work across borders like that?
Yeah, I'd say, just from my basic knowledge of geography and politics and things like that, the EU does seem to have a good reputation of cooperation. There seems to be, the way in which policy is developed, especially within energy, is developed from a top-down level. So the EU develops policy and then directs its member states to interpret that policy for each of its citizens, essentially, and then it trickles down to the municipalities and what have you. And I just thinking about the scale of the US and thinking about how different regions within the US have their own different systems, and sometimes there might be a bit of a difficulty in communication. And so, and honestly, please take this with a grain of salt, because my knowledge on this is not very good. But that's an example. And then in other regions, maybe some that are not as developed as Europe or the US, I think the barrier there would just be in terms of getting the opportunity to even do research like this, but mainly because needs in those areas tend to be more basic, tend to be more survival based, and not necessarily getting to the point where, all right, we have to look at energy poverty and things like that. We, you know, in a lot of these instances, we're looking at actual poverty, and so, you know, I guess those are certain barriers. But then, please, like I mentioned, I'm not well versed in the geography and geopolitics of different areas, but that's my take on it.
Cool. Totally appreciate the effort and the attempt. Thank you. Yeah, so Mariana, given all that and the first question, opportunities, exciting, let us know. What do you think?
Yeah, and I feel like there's a lot that I can say right now, because right now there's so much possibility within the Department of Energy, and there's so much momentum and excitement of what is to come. So I guess I'd start by the fact that, you know, this is a 2-year pilot program, but decarbonization will definitely be the focus of the Better Buildings Initiative and significant offices of the Department of Energy moving forward. So this carbon pilot informs that work. Right. So I mentioned heat pumps during our presentation. There's an entire team adjacent to the Better Buildings Initiative that's working exclusively on heat pump R&D, research and development, for those who are not familiar with that acronym. And they're constantly asking us what our partners saying, what our partners doing, and what are their experiences working with these technologies or trying to introduce them into their buildings. So that just like really exciting channel of communication and how we're informing other projects and just really forming a cohesive strategy focused on addressing climate change is what I think is the most exciting. And I would also add that there are just, you know, very sector specific obstacles that we're able to address through the low carbon pilot. And being the lead for the healthcare sector, I can speak to one that's pretty specific, and it's plug and process loads for radiology suites, right? So we're talking about MRI machines that are constantly, you know, using energy and incredibly energy intensive machinery. And that's something that our partners brought up to us. They're like, why don't we have energy efficient medical equipment, or we have some, but we know that we can go further. We know that we can push that envelope just a little bit more. So those very specific obstacles are brought up to us through the Better Buildings Initiative and through this Carbon Pilot program. So that's something I'm absolutely excited about. And I'll finish with energy equity and environmental justice. Right. And that's a huge priority for this new administration. And, it's something that we hadn't really tackled through Better Buildings in the past. But now, we're opening that door and we're having those very important conversations with our partners and asking them, how do you give back to your community? And how does your work, contribute to energy justice and environmental justice and energy equity in the United States? So we're starting those conversations, and that's also really exciting.
Cool. And I see Ben has tossed a question into the chat. Do projects in the DOE pilot have to pass a specific or suite of cost effectiveness tests, or is it more proof of concept?
No, they do not. These are partner-driven projects. These are their priorities and what they want to do. We're doing a lot more listening than talking. And it's those real world experience, right? Sometimes we're a little bit detached, right, in a government agency. So we really let our partners lead the way on that.